These are your instructions. In general, you just need to follow the PowerPoint. There are instructions in the yellow boxes on each slide. Please make sure the volume is turned up on your device so you can hear the narration. And remember, if a slide asks you for homework, don't forget to send it in via Show My Homework. If a slide asks for Educate to be completed, don't forget to do it by the date given. By the end of the lesson, you should be able to describe a simple model of the Earth's atmosphere and of atmospheric pressure, and be able to explain why atmospheric pressure varies with height above a surface. This is our starter activity. Why do bags of crisps swell up on planes? Stop the recording here while you have a think. To explain this, we need to know about atmospheric pressure. Crisps are bagged at or around sea level, and the pressure inside the bag is the same as the pressure outside. However, once the plane gets to a certain height, the outside pressure is less, which causes the bag to swell up. The first thing we need to know about the atmosphere is that it's a relatively thin layer of air around the Earth. If you thought of it as a piece of fruit, then the atmosphere would be about the thickness of a skin. If we take the radius of the Earth as being about 6,400 kilometers, then the majority of the atmosphere is contained in about 30 kilometers of space above the surface of the Earth. The atmosphere is most dense at the surface of the Earth. When we say that, what we mean is that at the surface of the Earth, there are more molecules of air per unit volume. The density of the air decreases as we increase in altitude, and altitude is just a word for height above the Earth's surface. It's important that we remember that pressure is just caused by molecules of air colliding with the surface. If we take that surface and raise it higher into the atmosphere, i.e. to a greater altitude, there are less molecules there to collide with the surface. So as the surface increases in height above the ground level or altitude, the number of air molecules above the surface decreases, and that means the pressure decreases. We can also show this in a graphical form. On this diagram, if we put atmospheric pressure up the vertical y-axis and altitude across the horizontal x-axis, as the altitude increases, you can see that the pressure decreases. So at sea level, you have a high pressure, and at the top of a mountain, you have low pressure. So to summarize, the atmosphere is a layer of air that surrounds the Earth. It is very thin compared to the size of the Earth. Atmospheric pressure is caused by air molecules colliding with the surface. As altitude increases, the atmospheric pressure decreases because, one, density, the higher the altitude, the less dense the atmosphere is, and so the fewer air molecules there are there to collide with the surface. And two, it varies because of how much air there is above a certain point. The higher the altitude, the fewer the air molecules, and therefore less weight acting on the surface. Here are some fact recall questions for you to try. And when you've done them, green pen your work using the answers on this slide. Here are a couple of application questions to test your knowledge. And you can green pen your work using the information on this slide. Your final task for this lesson is to send a photo of your work from this lesson to Mr. Rahman by Friday the 22nd of May.